Alright, hi guys. So today is a review day, day 2 of lesson 11.1. I'm going to pick and choose a few problems from the packet pages 3 and 4, and I'll post my answer key for pages 3 and 4. So take today to do the practice problems on pages 3 and 4 and check your answers. Let me know if you have any questions, and then also make sure you go onto the online textbook and do the homework assignment, okay? So I'm going to start. I'm not going to do like all the easy problems that I think you won't have any issues with. But of course, if you are struggling and need help, just reach out. But I'm going to start with problem number 7, one of the arc length problems. Let me draw up the diagram. This is again on page 3 in your packet. So problem 7, you're given this diagram here. You're given a circle P. And this is C, B, and then you have A. And you're given that the diameter, let me write this over here, sorry, that's P. The diameter is 28, and this angle here is 30. And the question and the directions for problems 5, 6, and 7 are asking you to find the length of this arc. Okay, and there is a formula that we used yesterday in the notes. To figure out the arc length, you take the measure of the arc, which is 30. Remember, if the central angle is 30, that means the arc measure is also 30. So you take the arc measure and you put it over 360. Because that's going to tell you what fractional part of the entire circle this represents. Then you multiply by circumference. Circumference is 2 pi r, so that's 2 pi, and the radius, the diameter, diameter is 28, so your radius, divide that by 2, is 14. And then you go ahead, you multiply and simplify. So first I can simplify the fraction, knock off the zeros, make it 3 over 36 times 2 times 14 is 28 pi. Then I can simplify this fraction even more. 3 goes into 3 once, and 3 goes into 36 12 times. So 1/12 times 28 pi. And then you're going to multiply numerators and denominators together. So you're going to have 28 pi over 12. Or I could have cross simplified there. Okay, I am going to simplify that fraction as much as I can. So what is the common factor between 28 and 12? That would be 4. 4 goes into 28 7 times, and 4 goes into 12 3 times. All right, so the length of the arc is 7 over 3 pi, and I didn't label, but in the diagram it was given as feet, so my units are feet. Okay, so that was problem 7. We're going to look at problem number 9, which, by the way, it looks like, problem number 9. Looks like there is no problem number 8, so if you get confused, it looks like that problem number was skipped. So problem number 9, the next problem, because 8 was skipped. We're given this diagram. All right. I think that is it. Yep, okay. So, and the directions ask you to find the perimeter. Find the perimeter of this figure. Okay? So the first thing you have to visualize, and it's not a perfect semicircle, but this is a semicircle right here. If I wanted to, right, I could draw a circle just for a minute to look at. And if I drew a circle, you can see that the radius of the circle is 4. So what would the diameter be? If I keep going up, the diameter, 4 and 4, gives you 8. So if that length is 8, that means, since this is congruent to this, we have 8, 8, and 8. And since they all three have the same tick mark, that's how I know they're all congruent. Okay, so what you can do is you can picture this as a square and a semicircle. Now we're finding perimeter, so we just need to add all the sides together. And remember, perimeter is the outside, so I'm not going to add this segment that's the inside. So I have 8, 8, 8, and then I have to figure out what is the length of this arc right there. Okay, so I can start first by saying the perimeter is equal to 8 plus 8 plus 8, and then I still have to add in this arc. Well, it's half of a circle, right? It's a semicircle. So, since it's a semicircle, that means the arc length, or the arc measure is 180 over 360. And then I'm going to multiply that by circumference. 2 times pi times r, which is 4. So what I have in parentheses here will give me the length of the arc right here, the semicircle. 180 over 360, because it's a half a circle, times 2 pi r. So let's kind of clean that up first. 180 over 360 simplifies to 1/2. Times 2 pi r, or 2 pi times 4 is 8 pi. Half of 8 pi is 4 pi. So now, if I bring down the rest of the formula, I have 8 plus 8 plus 8, and I can just add that together and simplify that to 24. I have 24 plus 4 pi. I'm going to drop the parentheses. I don't need those. All right, so 24 plus 4 pi. And again, it doesn't say to round, so that is exactly how you're going to leave your answer. Just label it, and there you go. If it did ask for an approximation, then you could use your calculator and plug that in, 4 pi, and then add 24 to it and get a decimal approximation. All right, so that was problem number 9. See, what's the next one I wanted to do? I think you guys will be okay with 10 and 11, the converting, but let me know. Flip it over to the next side. Let's look at number 8 on the next side on page 4. All right, so problem number 8. You're asked to find the circumference of circle F, okay, is what they're asking you for. And the diagram that's given, you're given a circle. It's circle F. And then you have this central angle, DFE. And what else are you given? You're given 46.75 feet. And then you're also given 290 degrees. Okay, so a lot going on in this problem. The first thing you should do is, if this angle here is 290 degrees, all right, and we know a full circle has 360 degrees in it, then I can figure out that the central angle DFE has to be 70 degrees. The 70 plus 290 will give you the 360. Okay, so that's the first thing I would do. Now, we are also given this 46.75 feet. And what that is the length of this arc right here. That is the length of that arc right there. Okay, now if we want to find circumference, let's just think for a second what information we need. In order to find the circumference of a circle, pi times d, or 2 pi r. So in order to find the circumference, I need to know the diameter and or the radius, right? If I know one, I know the other. So I have to work backwards in order to find the radius or the diameter. I'm going to use the fact that I'm given this arc length. And let's write down the formula for arc length for a second. So arc length is equal to the measure of the arc over 360 times circumference times 2 pi r. Okay, so I'm given an arc length. I'm given that arc length right there. It would be nice if I spelled length correctly. I'm looking at it and I'm like, that doesn't look right. Forgot the T. I'm given the arc length of 46.75. So let's fill that in. 46.75 equals the measure of the arc. So the arc length is 46.75. What is the measure of this arc? It was given as 290 over 360 times, we normally write 2 pi r, but that is circumference. So I'm going to leave it as C. And the reason I'm leaving it as C instead of 2 pi r is because the goal is to find C. So just make your life easier and leave it as C instead of 2 pi r. Okay, so now I need to solve for C. First, you might want to make that fraction more simplified by crossing off the zeros and make it 29 over 36, just to make the numbers easier to work with or smaller to work with, but that's up to you. To isolate the C, I have to multiply both sides by the reciprocal of that fraction. So I'm going to multiply both sides of the equation by 360 over 290. Right? 360 over 290. When I multiply it by the reciprocal, the fraction on the right-hand side cancels. So now I'm left with circumference is equal to 360 over 290 times 46.75. All right, so I'm going to pick up my calculator. I'll plug that in. Okay. So I have, I'll put it in and I'll show you guys. 360 over 290 and then times 46.75. Okay, and you get this fraction of 58.03448275. I think I read that backwards, or 276, sorry. Now, because the original problem had a decimal in it, it is appropriate to give a decimal answer. And for this one as well, it would be appropriate to give an approximated answer. Okay, so C is approximately 58.03, and it's feet. Right, the units were feet. Okay. So sometimes you will be using these formulas and having to work backwards in order to solve for one of the variables that is being asked for. All right. I think that is all I'm going to do. I'm going to leave the rest for you guys to try on your own. Again, I'm putting the answer key up so you can check as you go. This is not your homework since I am providing the answer key. You don't have to submit it to me, but you will have to jump onto the online textbook and do the homework that I posted on the online textbook. Let me know if you have any questions, and I'll see you back here for lesson 11.2. Bye.